Hey everyone, and welcome to The Explainer. Today we are tackling a really fundamental question for anyone in the Java world. How in the world do you configure a Spring application? It's a story that goes from super complex to, well, almost magical. So let's get right into it.
Yeah, if you've ever been stuck in an older Java project, this question probably gives you flashbacks, right? Endless, sprawling XML files. Before we can even appreciate where we are today, we've got to understand the problem that Spring was trying to solve in the first place. Okay, so picture any big application. You've got dozens, maybe even hundreds of different objects that all need to work together. This object needs that one, which needs another one, and so on. In the old days, you, the developer, had to manually create every single object and then connect all the dots yourself. It created this giant tangled mess of code that was an absolute nightmare to test and even harder to maintain.
So, along comes Spring with this revolutionary idea, a concept called inversion of control, or IOC. And honestly, this is the absolute bedrock of the entire framework. So, what exactly is it? Simply put, the control of managing all those objects gets, well, inverted. It's flipped on its head. Instead of you building all the pieces and connecting them, you hand that whole job over to the Spring framework. You just declare what you need, and Spring figures out how to build it and wired it all together for you.
And this really shows you the shift in thinking. On one side, the traditional way, you're basically a factory worker on an assembly line, manually building and connecting every single part. But with IOC, you become the architect. You draw up the blueprints, and the Spring framework becomes your automated factory, putting everything together perfectly based on your plan. This whole process, by the way, has a name: dependency injection.
So, back in the day, how did you actually give Spring those blueprints? Well, the very first answer was XML. You'd have these configuration files totally separate from your Java code, and inside them you define every single component, or bean, as Spring calls them, and exactly how they should be connected. And this is what it looked like. This little chunk of XML is basically telling the Spring container, hey, I need you to create an object of this createNewStock class, call it createNewStock, and make sure it has a property named newBid. Now, it worked, but you can just imagine, in a big application, these XML files could grow to be thousands of lines long. They became these giant, scary monsters that were a real pain to manage.
Yeah, the Spring team knew this was a problem. XML was just too verbose, and because it was separate from the code, it made it really hard to see what was going on. They knew there had to be a better, more developer-friendly way to do things.
And the solution was brilliant. Bring the configuration back into the code using something called annotations, all powered by this amazing feature called component scanning. So, instead of you having to list out every single bean in some XML file, you could just tell Spring, hey, go scan these parts of my project and just automatically find any class that I've marked as a special component.
And these stereotype annotations were the markers you'd use. Think of them like labels. @component is the generic catch-all label. But then you have more specific ones like @service for your business logic, @controller for your web layer, and @repository for your database stuff. Suddenly, Spring could understand the architecture of your application just by reading these simple labels in your code. I mean, look at this. The difference is just night and day, isn't it? All that chunky XML on the left gets replaced by a single, clean @service annotation right on top of the Java class itself. The configuration becomes super concise, and maybe most importantly, it lives right there with the code it's configuring. This was a massive win for productivity and just understanding your own code base.
But the story doesn't end there. Annotations were a huge step forward, but you still had to do a bunch of setup yourself. You had to enable component scanning, configure web servers, data sources, a lot of boilerplate. This set the stage for the next, and maybe biggest, revolution, Spring Boot. And its philosophy is convention over configuration.
The whole key to Spring Boot is that it's opinionated. Now, what does that mean? It means it makes smart, common-sense decisions for you. After seeing thousands of projects, the framework knows that if you're building a web app, you probably want a Tomcat server set up in a very standard way. So it just does it for you, automatically. No questions asked unless you want to tell it to do something different.
And this is the magic that makes it all happen: auto-configuration. It's Spring Boot's almost spooky ability to look at the libraries, the jar files, that you've added to your project and figure out what you're trying to do. It says, oh, I see you included the Spring Web Library. I bet you're going to need a web server and something called a dispatcher servlet. Don't worry, I'll set all that up for you.
So how do you actually tell Spring Boot what you're trying to build? You use these things called starters. And a starter is basically a one-stop shop for dependencies. Instead of you having to hunt down 10 different compatible libraries just to build a web app, you just add one single dependency, like Spring Boot Starter Web, and it pulls in everything you need, all guaranteed to work together.
Let's see how this works in real life. Step 1. You add that one Spring Boot Starter web line to your project's build file. Step 2. When your application starts up, Spring Boot sees all the web-related libraries that Starter brought in. And Step 3. Based on that, it just configures everything. It sets up all the necessary beans and even fires up an embedded web server for you. You've written 0 lines of configuration code to get a running web application. It's amazing.
Okay, so right about now, you might be thinking, this automagic stuff sounds cool, but what if I don't agree with Spring Boot's opinion? What if I need to do something custom? And that's a great question. But don't worry, this automation doesn't mean you've lost control. Spring Boot is specifically designed to get out of your way the second you want to provide your own configuration.
A really common way to customize things is by injecting values from a properties file using the @value annotation. Now you'll see 2 different symbols here. The $ syntax is the one you'll use 99% of the time. It just grabs a value straight from your application.properties file. The hash symbol, on the other hand, unleashes the crazy power of the Spring expression language, or spell. It lets you do things like perform calculations or even call methods right there in the annotation. Pretty powerful stuff.
Another super powerful feature for customization is profiles. I mean, your application needs to act differently when you're developing on your laptop versus when it's running in production, right? Profiles let you define configurations or beans that are only active in certain environments, and you can switch between them with a simple annotation, a command line argument, or even programmatically right in your code.
All right, so let's just quickly recap this whole evolutionary journey. We started with these explicit, kind of clunky XML files that lived outside our code. Then we moved to in-code, concise annotations, which was a huge improvement. And finally, we landed on Spring Boot, which is all about being automatic, opinionated, and favoring convention over configuration.
When you boil it all down, the history of Spring Configuration is really a story about one thing: a relentless drive towards simplicity. The goal has always been to get rid of boilerplate code and let developers focus on writing the business logic that actually matters, instead of fighting with the framework. And that really leaves us with one final thought. Now that so much of the heavy lifting of configuration is automated, what does that free you up to build? The framework is no longer an obstacle, it's an accelerator. The possibilities are wide open. Thanks for tuning in to The Explainer.